Okay, so we're recording. So let me read this part first. The velocity of a particle, p, moving along the x-axis is given by the following differential function. They call it v of p, fine. It's measured in meters per hour, and t is measured in hours, great. Selected values of the velocity of particle p are shown in the table above, and it is at the origin t equals 0, so that's the initial position. Sorry, yeah, that's the initial position. It's at the origin at t equals 0. Got it. Okay. So justify where there must be y, there must be at least one t from 0.3 to 2.8, at which v prime of t, the acceleration of particle p equals 0 meters per hour. Okay. This is going to be a mean value theorem question, just so you know. So this is dealing with MVT. For derivatives, just so you know. So you're focused on this interval, and very important, you want your interval to be continuous and differentiable for MVT to apply. Well, you're told it's a differentiable function, so duh, of course you're continuous, you're differentiable, and you're differentiable. So we're fine there. So why must we get an acceleration of 0? Well, remember, acceleration is a derivative of velocity, and even said so. The derivative of velocity is acceleration. Well, what you want to do is you want to find VP of 2.8 minus VP. This is part of mean value theorem of 0.3. So, you know, your A and B values, your high and lows of your interval. So this is your A, 0.3, and B is your 2.8 over 2.8 minus 0.3. Remember, it's mean value theorem. It's a little weird with the notation, but it's still something we're familiar with. We've done MVT before, mean value theorem. We did that fall semester. I think so. Or, no, that's going to be, was the beginning of this semester, but for those who had me for D period, they still saw this in the AP study groups, equals the derivative. And sometimes use the letter C. So there's some C value. And also if you think about graphically what's happening, you got some sort of funky curve here, right? And if you were to find the secant line, there's going to be a tangent line with the same value. That's what MVT is all about. Well, when you work this out, V of 2.55 and V of 0.3 is also 55. So you're actually subtracting the same numbers with each other. And so, yeah, you're totally going to have the derivative velocity equals 0, which is going to be the acceleration. So that's why that can happen. It's part of the mean value thing. We just show the secant line and set equal to derivative and show that that happens. So that's what you would do for that justification for that one. And again, you want to quote the mean value theorem. I'll show you the scoring guidelines just a little bit. Now part B, trapezoidal sum. So this is a Riemann sum in a way, but it's using trapezoids. So you want to approximate the integral from 0 to 2.8. So how's that going to look? Well, remember how trapezoidal sum works is that you put 1/2 on the outside. Hold on, it's being kind of silly here. Well, you put 1/2 on the outside. And you take the width of the first interval, which is 0.3, and you multiply to the sum of the y values there. 0 plus 55. Then you do it for the next interval from 0.3 to 1.7. That width is 1.4. Remember, these are trapezoids, right? So you have to do 1/2 b1 plus b2 times h, right? And that's going to be 55 plus -29. Plus, and then the last interval, which is width of 1.1, -29 plus 55, which is actually the same pair as before. And you can leave your answer like that. Just, you do you have to state the units? That's just going to be meters, I believe. Yeah. And you don't have to simplify if you don't want to. You can leave it like that. But if you were to simplify, you get 40.75, just so you know, for part B. Okay, questions about A or B so far? Let me show you the scoring guidelines just so we don't get too confused here. Okay. So you consider VUP 2 point minus VUP 0.3 is worth 1 point and use mean value theorem. I think that's really the best way to do it. They said another way I think they said that you could do is you can kind of consider extreme value theorem. I have to kind of wrap my head around that one, I suppose. Yeah, I don't know. I like the mean value theorem one. I'm trying to understand how. I guess you have a minimum. Or it has a minimum, whatever. So I guess you'd have a horizontal tangent, but then here again, that's a trapezoidal sum. They didn't put 1/2 on the outside, but that's okay. So you got that. Okay. So let's do C and D before I have you guys try on your own. So C. Ooh, a second particle, call it Q, moves along the x-axis with that function. So that's that velocity. Now find the time interval during which the velocity of particle Q is at least 60 meters per second. So I'll need to graph it. And find that this is traveled by particle Q during an interval when the velocity of particle is at least 6. So we got to figure out the interval first and then use that as our limits of integration. So in order to do that, well, I'm going to graph it. I mean, I don't have much of a choice. So go to my calculator. We go to y equals. Let's clear those junk here. And while I'm at it, I probably, well, no, sorry, I don't have another function here. Let me, okay. So 45 root x cosine 0.063. God, they would come some really nasty numbers there. X squared. Make sure your mode is radian. And you're going from 0 to 4. You want to at least be 60. So I'll probably keep that as -10, but then it takes up to 100 maybe. This scale's 10 perhaps. Okay. So what is that at least 60? Actually, let me graph y equals 60 while I'm at it. See where they intersect. That might make it easier. Okay. Option 5. 1, 2, 3. So 1.88, 1.866, okay. Let's find another one. Actually, before I get too carried away, let me store that So you hit X, store alpha A. So I store that. That just might make our answer more accurate. Go back to my graph. Second trace, option 5. Get 3.519.74. Quit. So now in this case, X, store that as B. Come on. Alpha B. Boom, there we go. Okay. So now, if you want to find the distance traveled, you simply just need to integrate our velocity function from A to B. And when you want total distance, you really should do the absolute value of velocity, but I don't think it'll matter because the velocity is always positive anyway here. But you go alpha window, option 4, alpha A, alpha B, alpha trace, y1, dx, and you get that. So the distance you traveled, and you should give the units, and round to 3 decimal places at least, 106.109, or you can cut off up to, you can also say 106.108 to accept that. But if you rounded too soon, if you said 106.1, you wouldn't get the answer. If you didn't write the units, you wouldn't get the point for the answer. So looking at the scoring guidelines, the part B is 1 point for the answer. But for the gained interval, that's from the graph, writing a definite interval is another point in the distance. I think if you didn't have the absolute, I think you'd have been fine because it was still gotten the same answer. Now, why do we have to be so accurate? Because if you think about it, what if I was a little too rough here? What if I made my, remember our first x coordinates was 1.866181. What if I just did 1.9 or 1.86, let's say? And let's say I did this one as it was 3.519, so it's just 3.52. And actually, let me round that one also, 1.87. My answer would have been off by a little bit. That is why you have to store this stuff. You have to store it because you're not going to get the point for the answer. It would suck that you didn't get it because you were so close. So they're actually assessing on precision and using the technology at your fingertips correctly so you get that precision. So there is a kind of a respect we have to have for that. So that's why I mean, you could type in more decimal points if you wanted to. I suppose that's fine, but yeah, so you gotta be careful there. Let's do part D, then I'll have you guys try 2018 number 2, which is a similar problem to linear motion. What do they want for that one? Let's go back to the problem here. Okay, part D. At time t equals 0, particle q is at that position. Use the result from part B, which is this is that p traveled, and the function vq, which is from part C, obviously. Approximate distance between them at t equals 2.8. Okay. Well, we know the answer was 40.75 from part B. Actually, we probably should have worked that out instead of just leaving it unsimplified. But it was 40.75 as a total distance traveled. And to find, excuse me, the position at t equals, yeah, because you want to find the difference between their positions, right? And actually, we know our initial position. So yeah, let's backtrack a little bit here. So bottom line is you want to find the difference between the positions. for points P and Q. At T equals 2.8. Well, initially you're at 0 for P, and you add it to its displacement, so that's 40.75. Okay. Now for here, you're given the initial position negative 90. So it's negative 90 plus its displacement. So you're going from 0 to 2.8 of the via QT function, which goes right here. Dt. Okay. So that's where I have to use a calculator. So alpha window, option 4, 0, 2.8, alpha trace, option 2, dx. Not option, sorry, it's y1, my bad. Took a little while, but you add that to negative 90. Well, not that long, just a little, just a second longer. So 45.93, and then you subtract them from 40.75 to get the difference between particles Q and P. So it's 5.187 meters apart. So looking at the solution key, you have a point for the integral, a point for the position of particle Q, which you know is negative 90, and then using that, and then of course 1 point for the answer. That's how you divvy up those points. Okay, so we got about 8 minutes left before the next group will come back in. What I'd like you guys to do is to try 2018, number 2. So here's 2018. It's also doing linear motion. So they want to accelerate. They give the velocity function, so you need to store that in your calculator. They also give you the initial position is negative 5. So they ask for the acceleration. They want the position at t equals 3. So you need to do the integral there. Also, they want you to interpret the meaning of the integral and the after value. They have a second particle, and at what time do they have the same velocity? So at least try A and B. A, you'll need to do a derivative, and B, you'll need to do an integral. So you guys have a few minutes to try that. So I'm going to kind of show you the answers for A and B right now. So you simply take the derivative of the velocity function to get the acceleration, which is negative 2.118. I don't think they gave us units there, so don't worry about that. But you do need at least 3 decimal places. So yeah, just store that equation as y1 in your calculator and just do the derivative. That's that simple. And for part B, you take your initial position, add it to the velocity, or you can think of it as the integral of the velocity is x3 minus x0, in case if they gave you x3 and 1 at x0, just so you don't mess it up. But the integral represents the net change, and add to negative 5, so you get the position is negative 1.76. So 1 point for the integral, 1 point for using the initial condition, 1 point for the answer. Now for C, evaluate that and evaluate that. So again, you can just use the answer. Now, when you take the integral of velocity, that's going to be your displacement for the first 3.5, whatever. I don't know the units for time here. When you do the integral, that's going to actually be the total distance. So that's the difference between the two. So displacement, total distance, just so you know. And lastly, for part D, the second particle moves. At what time are the particles moving the same velocity? Well, if you're given a position function for the second particle, you got to take the derivative, which is 2t minus 1. And you're going to set it equal to this velocity function right here. That's where you're going to graph and see where they intersect. That's what you're going to do. So 2t minus 1. And you simply are just setting 2t minus 1 equal to this. So you just graph 2t minus 1 and you graph this one and calculate and see where they touch. And they would touch at 1.571. And that's how, 1 point percent equal to each other, 1 point for getting the answer. But again, you're not going to be able to do that by hand. You have to use a calculator. Okay, cool. Okay, so, God bless you, Sydney. All right, so cool. Now we're going to swap groups. We'll do this for about another 25 minutes. So I'm going to work with the same people that were with Sydney. That's Ella, Ellie, John, and Sarah will be with me. We're going to be working on linear motion. The other three, Alex, Billy, and Brienne's, are going to go in Sydney's group. We're going to work on differential equations. You're going to be doing 2019 number 4 and 2018 number 6. For those who are here with me, we're going to talk about linear motion. So let me put you guys in the breakout rooms right now. Oh,